Hey everyone, welcome to my channel. And I want to talk today about a new course that I'm launching on Udemy. It's called Building Intelligent Agents with Large Language Models. My motivation for building this course was that I've been doing work in generative AI for a couple of years now, and I found that there's a lot of resources on doing simple prompts using a variety of models. But when you want to build more complex systems, the information is spread out. So I spent quite a bit of time just learning about agents. I think agents is the future because they allow you to build more complex applications that use reasoning and stuff more. And I put together this course. The course is meant to be very hands-on, and it teaches by learning, by building, by doing examples and stuff. And the good news is that it's available for free for the first 100 subscribers. So please check the link in this video to get your own Udemy link to redeem the course. And I also want to share a couple of videos from the course here. So I think a lot of people are confused on what LLM agents are. So these videos talk about the types of things, like what an LLM agent is, how is it different from just a simple LLM prompt, and what are the main components of the agent. So hope you like this. Please share your comments with me. Thank you. Bye. In this video, we will talk about some of the terms that are commonly used in generative AI and that will be used in this course too. So these include LLM, RAG, chains, and agents, and I'll try to basically tease out the differences between them. So let's start on the left here with the simple LLM call. So simple LLM call is what I think we all commonly do. Like, we have a question, we go to the LLM either through a chatbot type interface or through an API, and we get an answer back. So when we're doing this, we're using the inherent knowledge and ability that LLM has to answer those questions. So examples here could be, I have a pain in my tooth, what should I do, right? The LLM is going to use its own knowledge stored in its weights to respond back. A second type of way of using LLM is through what's called a retrieval augmented generation, or a RAG call. So a RAG is typically used to do question answering over a large database. And the standard process for that is that the database is the data that we have, the documents that we have are chunked and embedded and stored in a vector database. And then when a user has a query, the top K chunks that are relevant to answering that query are retrieved and given to the LLM as context. So an example here of the prompt would be something like that. Answer this question based on the context below. And what the LLM does in this case is it uses its ability to kind of read the provided context and its ability to synthesize a well-formed answer in the style that you want. And so this is very, very commonly used, and this is called the RAG use case. The third type of problem that I want to discuss here is what's called an LLM chain. And chains are what LangChains is typically used for. So this is also a fairly common use case. And the goal with the chain is that you may have a problem that is complex enough, and you are able to break it down into distinct steps, and you use an LLM for each of these steps, and you chain them together. So shown here, you have a prompt coming in, going to LLM1, and its output going to LLM2 that finally gives you the answer. So an example of this could be, let's say that I want the LLM to read a paper and then write an email with the key findings in the paper. So I can break this task into two tasks. The first task would be for an LLM to read the paper and summarize it. And then the second LLM would then use the summary as the input to then write an email explaining the findings from that paper. So the key distinction with chains is that you have to define the process a priori yourself by breaking the problem and by setting it up so that the chain, however long it is, can get to the answer. Okay, so I want to now talk about agents. So an agent, in my mind, is an is a system where you use the advanced reasoning capability of an LLM, along with ability to have memory about its own actions, about user, about knowledge of the external database, and then you use different tools that LLM has access to. You give the LLM the ability to plan out a task, and then essentially you use its reasoning to come to an answer. So with an agent, you give a prompt, and you do not have a very defined path, or the path that the model has to take may vary for each user or may just totally be undefined. And the goal is for the LLM that sits at the heart of this to use its reasoning to figure out, should I use a tool, should I use my memory, and do different actions, observe the outputs from those actions, and then keep iterating till it has come to an answer. So an example here of an agent may be, let's say we have an agent whose job is to interview candidates for a role, and then make an assessment on whether they are good enough to go to the next level. So an LLM like this would have access to maybe different tools, right? Tools where it has access to maybe external database to make, use to have specific questions, like maybe coding related questions that are relevant, right? Or it may have access to tools like an external database to write its output out there as it goes through the evaluation. But the idea here is that the LLM that's conducting the interview needs to change its strategy as it goes through the interview. And you actually start by maybe defining 4 or 5 things that the LLM has to ascertain by the end of the interview. And then as it goes through, as the interview flows, it will change what it needs to ask, and it will decide by itself when to ask different things, right? Maybe it asks the person a question and they do really well, and then maybe it's going to decide to ask a harder question, right? And so it needs to have the flow be defined by its own reasoning. And so as you look at this whole flow, the agent is the highest level of sort of complexity here. You sort of define a system that's capable of solving more complex problems, and that's going to be the focus of this course. So basically, and I think to kind of summarize here, that that we can have problems with different levels of complexity. The most simple is a simple LLM call, where it's a single step. You ask a question, you get an answer. Slightly more complex than that is a RAG call, where you get an answer, but instead of using the model's memory, you give it external data that it needs to use to compose the answer. The third level of complexity is a chain, where you can chain now different types of tasks to smaller tasks to solve a bigger problem. And the fourth level of complexity here is an agent, which is defined as a system that is going to be capable of solving problems that require reasoning by going through steps iteratively, observing the outputs, and then deciding its next action, and then finally arriving at an answer. Okay, so I think going on in the next unit, we'll cover a little bit more of the differences between a simple LLM and an LLM agent. Okay, I want to now talk about the main components of an LLM agent. So before I talk about LLM agents, I want to talk about what is an LLM agent, right? You may have heard the terms AI agents, LLM agents. Are these things the same? What all kinds of agents exist out there? So the way I think of this is that agents in general as a concept have existed for some time already, particularly in reinforcement learning. One example could be game-playing agents. So these may be agents that are in a game environment like a Go game or a Minecraft game, and then they learn to play the game by going through the process of playing the game many, many times and learning through that. So as agents too, they take action in the environment, they observe the outcome of those actions, and then they update themselves. But fundamentally, that process of updating themselves usually involves using reinforcement learning to change the weights of the underlying model, so that over time the learning gets captured in the weights, and we get a model that performs better. When we talk about LLM agents, I think that is fundamentally different. We are not going to be changing the weights of the LLM. In this case, the LLM is as is. We are going to be learning in a different way. We're going to be learning through the process of changing how we communicate with the LLM. So the idea is that we use prompts here to change the way the LLM performs an action, and this is something that is actually possible, right? There's a lot of research and there's a lot of different prompting techniques that show that the LLMs solve the problem differently if they are told to think about the problem differently. And fundamentally, this is also how humans learn, right? When we are in a new situation and we have to learn something, we don't really go and change the weights in our brain. We take actions, and we observe the environment, and we use language in some sense, right, to reflect on what happened and to tell ourselves what we will do differently next time. So when I think of LLM agents in general, I am thinking about using LLMs and the process of learning through language, by communicating, by reflecting, to improve. So that's the key idea here. So going back on the slide, I want to talk about the main components of an LLM agent. And I think there are 4 main components that we will be looking at in this course. And essentially, as we go through the course, we will get more and more sophisticated on each of the components till we can build a pretty complex agent. The first component highlighted here is tools. So tools are different types of, like, either Python functions or APIs that an LLM has access to, that it can use to get more information, right? So for example, there can be tools to access a user's calendar. There could be tools to access databases, to write to databases. You could have sophisticated calculator tools. You could have tools to search the web. And access to these tools give the LLM an option to get more information or be able to perform tasks better than it is itself able to do through its own weights. So that's tools. So tools are the key for an LLM to automate, right? To observe the world and to become more, to become basically better. The second piece that I've highlighted here is called planning, right? So planning is the ability to do a bunch of things. It could be an ability to plan a task, right? To be given a complex task, it can auto break itself into smaller pieces. Planning also involves reflection, right? So as you do a task, maybe we have specific skills or software or prompts that allow the model to reflect on what happened to improve itself. So planning is the key step here, because it is what enables the multi-loop of the LLM agent, because it allows it to break the problem and to assess itself as it goes through it, to improve and get to the answer that the user needs. The third thing here is memory. So memory is something that all chatbots have. So I think that most people here would be somewhat familiar with the concept of memory. So when it comes to an LLM, you can think of them as having 2 kinds of memory. One is the short-term memory, and this is the memory that goes into the context window of the model. So often with chatbots, this includes previous chats that the bot did, so that, as it kind of responds back, it has information of what it said before, what the user said before. But they can also be long-term memory, and long-term memory is typically inside the weights of the LLM, but it can also be memory stored in a database, and that's what RAG does. It accesses this long-term information or memory stored in a database and brings it to the model. So memory is a key component here, because it allows the model to basically reflect, like it allows the model to know what it did, to be able to see its own actions, to be able to see what the user said, and to access world knowledge too. And then finally, I think that the center of all of this is the agent, or the agent core, which is the central LLM, which ties all of these things together. It has access to tools, planner, and memory, and then it uses that to take action, and then it reflects on the actions, and it does this itself in a self loop till it is able to solve the problem, or it decides that the problem cannot be solved. So this is what an LLM agent means to me, and this is the type of system that we will try to build in this course. So I want to touch on one other thing. There's an excellent blog by Lillian Wang that I have highlighted here. I'll include the link in the resources as well. So this is what this kind of blog looks like. It's a very good overview of what an LLM powered agent looks like, and it covers on mostly the things that we've sort of talked about here, but I would encourage you to sort of look through it. There's an interesting piece here that I wanted to cover on is okay, so as part of this, I want to also share another agent to give an example of different types of agents that can be built. This is an agent that that's able to synthesize new chemicals by combining an LLM with chemistry tools. This is an interesting paper as well that I will cite. I will include in the resources. This is called a ChemCrow agent. And what this agent does is that it has access to specific tools that are relevant in chemistry. So these includes tools that allow it to plan and execute for a chemical process. It has tools, general purpose tools like access to literature. It also has tools to do some sequence of actions to make material and stuff and test on them. It has access to molecular tools. And what this paper did is it combined all these tools with an LLM and had it go through loops of having an idea, selecting a tool, executing the tool, observing the output, and as they through the paper they're able to show that using this loop through which the central LLM went through, they were able to synthesize actual chemical that's used for insect repellents, right? So this is an interesting application of using an agent and tools and thinking and stuff to build systems that are able to solve more complex problems. So in the next video, I want to talk about another such tool called GPT Researcher, and I'll try to show you how that's another way of, like, it's a different kind of tool than this one, but it highlights the core components of the agents again.